everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this integral to solve. Integral of x to the power 3m plus x to the power 2m plus x to the power m times 2 to the power all that expression. Let's solve this considering that x is greater than 0 as it's given the condition. Okay, we analyze that we have x to the power m all to the power 3, x to the power m all to the power 2, x to the power m, and so on. So since we have x to the power m in various expression, we can let x to the power m to be a variable. So we can let x to the power m to be equal, for example, to t. And doing that, we can isolate the value of x. How do we isolate x here? So we can put both exponent, we can put both expression to the power t 1 over m. So if we put both exponent as 1 over m, we can cancel out these. So we're going to have x will be t to the power 1 over m. Okay, perfect. Now we can differentiate both sides. We're going to have dx equal, the derivative of this expression is applying power rule. It's 1 over m t to the power 1 over m minus 1 dt. Show that we differentiate with respects to t. Okay, so this is the same here, where there is minus t is the same as t times negative 1 dt. Okay, which is also the same as 1 over t dt. Right, so it's the same thing. So if we substitute in our given integral, we're going to have, here will be, we have x to the power m3, so we have x is equal to t to the power 1 over m. So where there is x, we can substitute by this expression, where we let in the beginning, x to the power m to be t. Remember, we said x to the power m to be t in the beginning, before we apply this approach then. Okay, so where there is x to the power m, we can put t, so we're going to have t to the power 3 plus, here it's x to the power m2, so it's gonna be t squared plus t times 2t squared plus 3t plus 6 times all to the power 1 over m dx. But we said that dx is this expression, so it's going to be 1 over m t to the power 1 over m times 1 over t dt. Okay, perfect. Now, 1 over m we are solving considering is a constant, so it can come outside. So we're going to have now 1 over m. Now it's outside. If we check, this exponent is the same as this exponent, so we can multiply this expression and this expression. Since they have the same exponent, we're going to keep the exponent and multiply the bases. So what happens now with 1 over t? 1 over t I can multiply with this expression. So I can have t cubed plus t squared plus t over this t here. Okay, times this expression multiplying this, they will have the same exponent, which is 1 over m. We will keep it. And we multiply t times 2t squared, go ahead, it's going to be 2t cubed plus 3t squared plus 6t. That's what we have here. Okay, now if we check, we can divide these two expressions because it's this expression dividing by t. So if we divide this expression by t, this is gonna reduce from t cubed to t squared, this from t squared to t, and this from t to 1. So this expression is the same as writing t squared t plus 1. Okay, we can reduce into this expression. Perfect. Now, having this expression, if we check, the derivative of this expression can give us this expression. So we can still let again, we can let, that's 2t cubed plus 3t squared plus 6t to be equal to a new variable. We used t in the beginning, now we can use here a. So if we differentiate, we're going to have the derivative of this expression will be 6t squared plus 6t plus 6. We differentiate with respect to t, and the derivative of a will simply be 1. So dA, to show that we're differentiating with respect to a. Now the thing is, this expression is not the same as this one. But what if we factorize 6? Because 6 is common number. So if we factorize 6, it's going to be like this. It's exactly the same as this one. So this expression we have here, dt, and this expression, but we don't have 6. So this 6 that is multiplying, we can isolate, so it can come here, dividing, so it's going to be 1 over 6 dA. Okay. Now this expression here is this expression and this expression, which is 1 over 6 dA. And this expression will lead to be a. You see how fascinating this problem is getting. So it's going to be, this is going to be equal 1 over m times this expression and dt, we said it's 1 over 6, and this expression is a, so it's going to be integral of a to the power 1 over m times 1 over 6 dA. So what happens? This 1 over 6 can come outside, so we're going to have 1 over 6m, and the integral of this expression is going to be times a to the power 1 over m plus 1 over 1 over m plus 1. So it's getting interesting. So it's very easy, this problem. So we can now find that operation, the result. What's going to be 1 over m plus 1 over m? We know it's going to be m plus 1 over m, the same here, m plus 1 over m, if we calculate. So since it's in the denominator, it's 1 over this expression, we can apply the division of two fractions. It's multiplying the first one by the inverse of the second one. So it's going to be 1 times this expression. So we're going to have 1 over 6m times m over m plus 1 times a to the power m plus 1 over m. But now the question is, this m and this m, they can cancel out. So we're going to have, this is going to be equal to 1 over 6 times m plus 1 times a. But what's the value of a? The value of a, we let from the beginning, here, from this beginning, which is this expression. So which is going to be 2t cubed plus 3t squared plus 6t to the power m plus 1 over m. But that's not the final result. What is the value of our t? What's the value of t? We let here, t is equal to x to the power m. So it's going to be 1 over 6 m plus 1 in the denominator. So 2t is x to the power m, so x to the power 3m plus 3x to the power 2m plus 6 x to the power m, all to the power m plus 1 over m plus c. So that is the solution of this given integral. Okay, it's fascinating and interesting. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.